Hello again. Okay, so in the last video we talked about what happens with subtracting fractions in a way that sort of relates to this borrowing scenario in whole number land, right? I can't just move the 7 down. I have to borrow and bring the number all the way over, right? Now we're going to look at some fraction subtracting that relates sort of more to this problem, okay? So instead of having zeros up here, I have numbers, but the numbers are smaller than this number down here. Well, I can't take 7 from 1, so I still have to borrow. But what's important is that what I'm borrowing, I'm adding back to what's already there, okay? And so that's very, very critical when we get to borrowing fractions and there's already a fraction there. Let's look at an example. Here I have 20 1/8 and I'm subtracting 9 5/8. Okay, so over here, this part probably not any problem, because remember I'm going to subtract my my whole numbers separate from my fractions. But look at this. Can I take 5 from 1? No, I can't. That 1 is smaller. So I have to borrow, okay? And so here's what I'm going to do. There's a couple of different ways to think about it. I'm going to show you the one way first, and then I'll show you on another problem sort of the more of a shortcut way to do it, okay? So I can't take 5 from 1, so I have to borrow. I'm going to come over here, make this guy a 19. And just like in the last video, I'm going to move that 1 that I borrow over here and write it as some fraction that equals 1, so some number over itself. Okay, since I already have 8s on the bottom, right? Look at that. 8 and 8. I'm just going to make it 8 over 8. Because then I don't have to find a common denominator, and I'm making a lot less work for myself. I'm all about not having too much work to do. Okay, now we're going to add these top numbers together. So 1 plus 8 is 9. My bottom number stays the same, okay? Now, this number is bigger than 5, right? I can totally subtract that now. 9 minus 5 is 4. My bottom number stays the same, and then I'm going to come over here and subtract my whole numbers separately. So 19 minus 9 is 10. So now I need to ask myself the two questions again, like I always do at the end when I have an answer and I think I'm finished. Number 1, is this a proper fraction? 4 is smaller than 8, so yes it is. Number 2, is it reduced down as far as it can go? And in this case, no, it's not. So I have to figure out what I can divide out of both of those guys. What can I divide out of both 4 and 8? I could do 2, right? That's a common factor of both 4 and 8. But I could also do 4. And that's going to reduce me down a lot quicker than I would be able to reduce with 2. 4 divided by 4 is 1. 8 divided by 4 is 2. And my 10 comes straight over. So there is my answer. So 20 1/8 minus 9 5/8 equals 10 1/2. How crazy is that? Let's look at another example, because again, I want to show you if this way doesn't make a whole lot of sense to you, to kind of see all of those steps, there is another way to look at it. So let's do a problem with the other way of looking at it. Okay, so here I have 30 5/9, and I want to subtract 27 8/9. And so again, I'm dealing with my whole numbers separate than my fractions, right? Can I take 8 from 5? Oh, bummer, I can't, right? Because 5 is smaller. So I have to come over here, borrow, okay, bring the one that I borrow over, and rewrite this guy as a fraction. So here's a shortcut way that I could do that. I could say 9 and add 5 to that, because I know I'm going to use 9. I have 9 as my common denominator, right? I know I'm going to use 9. 9 plus 5 is 14. So I'm going to cross this guy out and write 14. So if you're like, what just happened? Really what I did is I borrowed 1 from here, made this 29, and came over here and added 9 over 9, which is 14. Oop, I'm running out of room there. 14 over 9, right? But for some people, seeing all of this work is too much, so it might just be easier for you to cross out that 5 and put a 14. Now, you cannot, I'm going to write this in red because this is not what we want to do. I don't want to take 30 and borrow 1 from it and come over here and just go like that. That is not what I want to do. I have to, it's not going to be 15. I'm not adding 10 to it to make that 5 a 15. I'm only adding 1. But it's, you know, we're in fractions, so it has to be added like this. Okay? So over here what I did is I said 9 plus 5, 10, 11, 12, 13, 14, and crossed it out and got 14. Let's finish this problem out the rest of the way. Okay, 14 minus 8 is what? 6, right? Bottom number stays the same. And now I'm going to subtract 29 minus 27. That equals 2. Okay, so now I have this answer. I have to ask myself my 2 questions. Number 1, is it a proper fraction? And yes, it is. 6 is smaller than 9, so we're all good. Proper fraction. Question 2, is it reduced down as far as it can go? Hopefully you're beginning to sort of see when things need to be reduced down. You know, you kind of start to get that gut feeling like, hey, wait a minute, something needs to be done here. And in this case, yeah, I can divide something out of both of these. They have a common factor. Their common factor will be 3. Okay, so 6 divided by 3 is 2. 9 divided by 3 is 3. And my whole number 2 just comes straight over. So there is my answer, 2 2/3. So 30 5/9 minus 27 8/9 equals 2 2/3. Okay, you might be saying that looks easy enough, but I'm going to try to throw one more little wrench in the works here too. What do you notice about these guys? They don't have a common denominator. So that's still going to be your first step. So I have 3 and I have 12. My least common multiple of both of these numbers that I'm going to use as my common denominator is 12, right? And again, that's super nice down here because that means this guy stays the same. 12 times 1, so 11 times 1. But 3 times something gives me 12. What is it? Times 4. So then I multiply the top number by 4. So now I have 4 twelfths minus 11 twelfths. Oops. Can I do that? Oh no, I can't do that, right? What am I going to do? Borrow. I have to come over here and take 1 away from that 7, right? And I'm going to go back to doing this the first way just so you can see all of the steps. But know that I could just add these 2 guys together and change the top number, right? So that 1 that I'm borrowing, I'm going to bring it over here and write it as some number over itself. And since I now have found that my common denominator is 12, I'm going to make it 12 over 12. Okay, so there's the 1 that I borrowed. I'm going to add it back into what was already there because that's super important. So now I get 16 twelfths. And now this number right here is bigger than this number right here, so I can subtract. 16 minus 11 is 5. My bottom number stays the same, right? And then I come over here and subtract my whole numbers. So 6 minus 4 is 2. So now I have to ask myself my 2 questions. Is it proper? Number 1, yes it is. 5 is smaller than 12. Number 2, is it reduced down as far as it can go? And in this case, 5, if you notice right there, is prime. So I can't reduce it down anymore because it would have to divide evenly into 12, which it doesn't. So I know that that's my answer. So 7 1/3 minus 4 1/12 equals 2 5/12. Let's just look at one more example to make sure that you've got it. Because again, this is really where the subtraction piece gets tricky. 22 5/8 minus 8 6/7. First thing I have to do, common denominator. Oh my gosh, the least common multiple of 8 and 7, I think, is 56, right? 8 times 7, they don't have anything in common before that. That is a super huge number, but that's okay. We can totally do this. Alrighty, so 8 times what gave me 56? Well, it was 7. So now I multiply my top number by that. 7 times 5, 35. 7 times what gave me 56? Well, it was 8, right? So 6 times 8 is what? 48. So there I've just found my common denominator, right? And converted my fractions all over. But now, can I take 48 from 35? No, 35 is a smaller number. So I gotta borrow, right? And bring that one that I borrow over here, and I'm going to add it back in. Since 56 is my common denominator, that's how I'm going to write my fraction that equals 1, 56 over 56. And now I'm going to add it back into what was already there. Ay, 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 this is going to be a big number, right? 91 over 56, because 35 plus 56 is 91, okay? Is 91 larger than 48? Absolutely, it totally is. So now I know that I can subtract. 91, I'm going to come over here and kind of do some subtraction over on the side because I can't do that in my head. See, I got to do some regular whole number borrowing, right? But I find that my answer is 43. Okay, I'm going to come back up here. 43, my bottom number stays as 56, and then I'm going to come over here and subtract my whole numbers, right? And again, I'm going to come off over to the side here because I could probably figure that out, but it's easier to do it this way. 11 minus 8, 8, 9, 10, 11 is 3, right? 1 minus 0 is 1, so my answer is 13 and 43 56ths. Now, is this a proper fraction? Yes, it is. 43 smaller than 56. Is it reduced down all the way? And I think, in this case, it is. I think that 43 is prime again. So the only way that it could be reduced down is if 56 could be divided evenly by 43, and I don't think it could be. Yeah, I don't think it can. So, there is my answer. 22 and 5/8 minus 8 and 6/7 equals 13 and 43 56. 56. That's hard to say. Alrighty, so we are going to practice this in class tomorrow. We'll have lots of practice with this because it is again taking it to the next level, adding that extra step to subtraction, and we are totally going to do this. You guys can do this.